Right, in your reading today, you read about chemical bonding. And so I want to kind of distill that down for you and give you 5 big ideas from your reading that I want you to understand. Okay, first off, chemical bonding hooks atoms together to make molecules. Now, a couple of chapters ago, we talked about the difference between atoms and molecules, but we didn't really talk about how atoms hook together to form molecules, and that's what we're going to get into now. So if you have an atom and you have an atom and you hook them together, you're going to make a molecule out of it, okay? Secondly, bonding happens because it makes atoms more stable. If you recall that I said that anything in group 17 really wants another electron so it can look like a noble gas. And so these guys are very reactive. They're not very stable because they're so unhappy with who they are that they want another electron so they can look like a noble gas. Same thing is true of this first column over here. These guys want to look like a noble gas so badly, and it's relatively easy for them to do so because all they have to do is lose an electron. And so these guys here are also very reactive. And so once these guys have lost this electron, once these guys have gained this electron, they are much more stable. And so bonding happens because it makes atoms more stable. It gives them that full outer shell of electrons that they want to have, and then they don't want to react anymore once they've achieved that full outer shell. We use something called the octet rule, and you're going to hear me talk a lot about that in the next couple of videos. Octet, if you have a group of 8 people singing together, it's called an octet. Well, the octet rule just means that these atoms want to have an octet of outer electrons. They want to have 8 valence electrons just like the noble gas does. So they're going to try to obey the octet rule and get that full outer shell. Okay? Third big idea. Atoms can bond to other atoms that are of the same kind, or they can bond to atoms of different kinds. So you're very familiar with H2O. You've probably seen that a whole lot in your life already. And so H2O just means that you've got H, which is hydrogen, and O, which is oxygen, and they have bonded together. Obviously, those are atoms of 2 different elements making one molecule. So those are atoms of 2 different kinds. However, they can also bond to atoms of the same kind. So oxygen, as an example, will bond to another oxygen atom, and it will make a molecule of oxygen. Nitrogen will bond to another atom of nitrogen and make a nitrogen molecule. And so we have several atoms or several elements that will bond to themselves in order to achieve this full outer shell of electrons. So fourth big idea is that atoms can bond, they can achieve this outer shell, full outer shell of electrons in one of 2 ways. They can either share electrons or they can transfer electrons among themselves. Remember when we were talking about energy and how conservation of energy, we said you can't create energy and you can't destroy energy, you can only change forms? Well, in a similar fashion, atoms can't just pull an electron out of thin air. They also can't just throw an electron away. It has to go someplace. And so they can transfer electrons to another atom. They can transfer them from another atom to gain them. Or sometimes, if the desire is not strong enough to transfer them, then they can just share electrons with each other to gain that full outer shell. And we'll talk about both of these ways of bonding here in the coming days. So finally, 5th big idea is that the properties of compounds, or the molecules that we were talking about, the properties of compounds are different from the properties of the elements that make them up. Okay, so elements, you have atoms of an element and you have molecules of a compound. So let me give you an example here. Another formula that you've probably seen, we mentioned H2O already, and we said that means that you've got 2 atoms of hydrogen and an atom of oxygen that go together to make a molecule of water. So 2 atoms of hydrogen, 1 atom of oxygen, and makes 1 molecule of water, okay? Another formula that you have probably seen is NaCl, okay? Do you know what that is off the top of your head? Does that look familiar? NaCl is table salt, the very thing that you will sprinkle on your food at dinner time to make it a little bit more tasty. Sodium by itself is a metal, and so it is very, very shiny. It's very smooth, it's very reactive. In fact, if you take a hunk of sodium and you drop it into water, it will catch on fire, believe it or not. Chlorine, in its natural state by itself, is a gas. It's got kind of a greenish color to it. And so I'm taking something that is a shiny metal that causes a fire when I put it into water and putting it with some sort of a greenish gas, but yet when I put them together, and chlorine is also poisonous, by the way, if I put these two together into table salt, I get something that's totally different. I mean, if you have a big pot of water on the stove and you're going to make spaghetti, you put salt in that water, it certainly doesn't catch on fire just because you put salt in it. Even though that salt contains sodium, the salt has completely different properties than either the sodium or the chlorine. And that's what happens when we make molecules of a new compound. They have completely different properties than they did from the elements that make them up. Okay, so these are the 5 big ideas that I want you to get out of your reading from today, and we'll go into a lot more detail about these things in the next couple of videos.